Hello, and welcome back to the Raw Code Academy. I'm your host, David Flanagan. Today starts the first video in my course, The Complete Guide to Cubescape. This video is made possible by the amazing team at Armo, who kindly sponsored my time so that I could make this course for you. So, what is Cubescape? Cubescape scans Kubernetes clusters, YAML files, and Helm charts, detecting misconfiguration according to multiple frameworks. Frameworks such as SYS, NSA SISA, and MITRE ATT&CK, and a few more. As well as misconfigurations, it scans for software vulnerabilities and RBAC, role-based access control, violations. You can do this at early stages of your build pipeline, as early as on your machine as you're writing your code, perhaps in CI/CD. And today I'll be taking a look at running Cubescape in your cluster for continuous scanning of misconfigurations and vulnerabilities. Now, the answer isn't to pick one or the other, but possibly all of the above. Because Cubescape calculates a risk score instantly and shows you trends over time. The more you scan, the more benefits you're going to get. I've had a lot of fun experimenting with Cubescape this past week, and today's video will show you how to get started, continuously scan your Kubernetes cluster in cluster with the Cubescape operator, and use Cubescape Cloud to visualize and consume that information. Let's dive in. Okay, so how did we set up this cluster? All this code is available online at github.com/rawcodeacademy. There you will find a repository called the Cubescape Complete Guide. This uses some Pulumi automation to spin up a brand new cluster on AKS, EKS, and JKE. You can see here I've got simple helper functions to create each of these clusters. Feel free to do this once for any part of the Cubescape course that we're going to be working through today and subsequent days. Feel free to reuse this automation if it makes sense for you. Now, because we're going to use Cubescape in cluster and Cubescape Cloud, we do need to provide our account ID. You can get this by logging into Cubescape Cloud and go to your settings page. I'm storing this in a Pulumi secret value so that it can be consumed and injected into my Kubernetes clusters when I run Pulumi up. There's just a little bit of glue needed to configure the providers in a format that we need to do multiplexing. That is, using Pulumi to deploy a single resource to multiple clusters. From here, we can loop over each of our providers, and I'm deploying Flux2, Grafana, and then Cubescape. Why am I deploying Flux and Grafana? Well, we just want to see a few extra data points as we scan our clusters with Cubescape. Cubescape provide a wonderful Helm chart that allows us to deploy their cloud operator. You can find it at kubescape.github.io/helm-charts. The chart is very easy to configure, and that all I really need to provide is my account ID and the name of my cluster. For my cluster name, that is AKS, EKS, and JKE. Nice and simple. When I run a Pulumi up, I'll have 3 clusters, all with Cubescape installed, and I can go straight to Cubescape Cloud. So let's take a look at the Cubescape Cloud dashboard. On this homepage, you'll see the 3 clusters that I spun up in preparation: AKS, EKS, JKE. Promise is the last time I'm going to say that. We have 2 tables, one for configuration risk and one for vulnerability risk. Configuration risk is going to show you all the opportunities that you have to fix your Kubernetes manifests and Helm charts to represent what the industry considers best practice. This comes from a bunch of different frameworks like NSA, MITRE, DevOps Best, SYS, Armo Best, and all controls. If we want to take a look at the SYS framework and see which controls fail, we get so. If we want to look at MITRE, NSA, and so forth. If we want to look at all controls, boom. And what this is changing is the violations or control failures over time. You can see here that when I first deployed Cubescape to these clusters, we had these violations across these clusters. We can see JKE and EKS here. We move across and then the numbers change, and then the numbers cross and they change again. In theory, the longer that you have Cubescape deployed, and the more that you're deploying to the cluster, we live in an age of Kubernetes and microservices. It's not uncommon for clusters to have hundreds, maybe thousands, maybe even tens of thousands of workloads in them. And those workloads, because they're microservices, evolve and deploy quite fast. It's not uncommon to have tens of thousands of deployments per day. As those manifests change, as you're evolving them, maybe they're shared. Maybe you have a common base that you use to deploy all your web apps. And a change there could actually have a huge cascading failure alert, or at least failed controls, when they propagate down the stack. So you can use this little table as a way to see if you've got any major incidents where you see a peak and then a trough, which could be a break and a fix of those manifests across your cluster. My table looks a bit weak and a bit bland, and that's just because these clusters aren't that old and the agent itself hasn't been running in it very long. However, there are a few changes that we can see over time. On the right hand side, we have the failed controls, and the color of the bar indicates the cluster, which is the violations of the failed controls, and then the length of the bar is the number of times this has been hit across your workloads. And if we click on one, we get taken to the Cubescape documentation. This is fantastic. This tells me the ID number. So here we're looking at C0050, which is resource CPU and limit request. The workloads in my cluster don't have this by default, not all of them at least. So we get which framework this rule applies to. So DevOps best practice, all controls, and YAML scan. The severity of this is high. Obviously, if we don't specify resource limits and requests for CPU and memory, then our applications won't schedule properly. They could potentially consume more memory than we want them to, and saturate that for other workloads on the cluster. We get a description telling us why this control is important. We also get related resources. These are the resources that this control can be detected on. So cron job, daemon set, deployment, pod, jobs, replica set, and stateful sets, of course. And then we have a remediation path. If you want to get rid of this failed control, set a CPU limit or use exception mechanism to avoid unnecessary notifications. And then we have the configuration that we can change on those resources to make this failed control a successful control, passed control. I'm not sure. Not a failed control, at least. Well, let's pick on one more. This is from a different cluster. We have C0034, automatic mapping of a service account. This is ARML best, NSA, all controls in YAML scanning with a medium severity. Now, all my clusters run on the default for the cloud provider. So AKS and EKS and JKE all run, I said that was the last time I was going to say it, all run 123 by default. So these are 123 clusters, which means they're not 125 clusters. Kubernetes 125 is when the automatic mounting of a service account was disabled. So in any cluster older than that, when you don't realize it, all your pods have credentials to speak to the Kubernetes API server with some level of permissions. And this is not something that you really want all of your workloads to be able to do. Why should Nginx be speaking to my Kubernetes API server? So we have the related resources. This is everything that can run a pod, essentially. It tells you about the control test, and then the remediation is to disable the automatic mounting. And it gives you an example of what that looks like. So we set auto-mount service account token to false on our service account. You can even do this on a workload itself. So you have a couple of options. So this first configuration table is really great. We see those failed controls over time. We can monitor for events with cascading failures. And we have the ability to just get a quick view of the top five failed controls so that we can start to reduce that number with the controls that are potentially easiest to fix. The second table is the vulnerability risk. This is now moving beyond misconfiguration and actually scanning the images that our applications run on within our cluster. This is scanning for known CVEs. CVEs are plentiful and bountiful, and they just keep on coming. As you can see here, across our workloads, we've got 36 critical, 165 high, 190 medium, 36 low, a whole bunch of negligible, and some unknowns. So this can be very difficult to prioritize and action. I see this time and time again as I work with organizations. Some of them have taken steps to do some scanning, but the remediation factor is difficult because there are just so many of them by default in some of these base images. If you're using base Ubuntu, base Red Hat or CentOS, etc., CVEs are there thick and fast, and unfortunately the base layers aren't being built quick enough to maintain or keep up with the changes. Now, we can use the critical and high as a benchmark to say we probably want to fix these, but doesn't mean you can neglect the mediums, lows, negligibles, and unknown. They still require some manual scanning, someone to review and understand. Can we fix those? It could be the 190 mediums are actually relatively easy lift, and you can wipe them off the face of the earth with one change. Unlikely, but potential and plausible. Now, even at the critical and high, we're still close to 200 failed controls. So, like we can with the configuration one, we can see the change over time, and we have the top CVEs on the right. What I love about this table is it has 55 WL. This is showing us that 55 workloads are affected by this CVE. Now, we can drill in on this by clicking on it, and we'll be able to see the workloads that this affects. Now, obviously, we've got 55, so it's quite a lot. But we can see that Flux is affected, Grafana, Flux, ECR stuff, Cubescape itself, and Microsoft. So this is a very broad spectrum CVE that affects a lot of base images. It could be they all rely on the same base layer and they all need updated. It's hard to tell. However, what we can do is filter on the top here. One, we can turn on this flag, which tells us which of these have remote code execution. These are the ones that we probably want to try and fix first, even if they're medium, even if they're low, even though a low RCE probably wouldn't be low, because these are the ones that allow somebody potentially to run commands within our cluster. Now you might be thinking, well, my pods aren't publicly available that these images are on. However, remember lateral movement within a cluster is an attack vector that you need to be very careful with. So even if you feel that your workload isn't available on the public internet, if you have any workload available on the public internet, lateral movement is there. So be cautious. However, we can see that we can fix, or there are 6 criticals that have an RCE and 11 high. Those are the ones I probably want to prioritize first. However, there's one more toggle on the screen, and it's, is there a fix available? This is your low-hanging fruit. The golden path here is that the ones with RCEs have a fix available and we can knock them out together. And what we see is that of the criticals, we have 19s that have a fix. We have 44 that have a fix on high and 78 mediums with a fix. So we're able to drastically reduce these numbers as long as we know which workloads and how to apply the fix. And that's why scrolling down now becomes even more important. What we can do here is take a look at this path here. So on this JKE image, 10 criticals, 8 fixes, 20 highs, 11 fixes, 15 mediums, 8 fixes, and then the lows. So let's click on this. And from here, we'll see the image scanning report for this netd image from JKE. We can scroll down to the bottom, and it now shows us the individual CVEs that have the fixes available. We can see that the first CVE, 213999, was in libc-bin. We can see here that it's a high severity fix available, and the upgrade path is to change from 231.13.deb11u3 to u4. And in fact, all the fixes here are a small update to the Debian package. So while I can't change the netd JKE image myself, let's assume this is my own workload in a cluster. And right now, in fact, it's very common for organizations to all share a common base layer if they're using a base layer and not something like Distrolist or Scratch, etc. But if you are using Alpine or Ubuntu or CentOS as that base, it may be quite common for these same issues and failed controls in the vulnerability scan to be quite common and persistent across all of your images. And it could be that rebuilding that base layer is a very not easy, but maybe trivial way to roll out that fix fast across your entire fleet. So what Cubescape is doing from this dashboard view with both the tables for configuration and vulnerability is giving me a way to identify the issues that deserve my attention. By using the top links on the right, we can drill that down to the ones that have the most bang for buck or the ones that affect the most workloads. From there, we can identify the images that we need to be looking at, and hopefully, using the nice toggles with RCEs and have fixes, we can identify the ones that deserve our attention first. From there, we can plan out a remediation path as a platform team or SRE team and roll out those fixes across our fleet. And that all took less than 10 minutes. So I'm really impressed with Cubescape Cloud so far. The fact that I was able to find a dashboard, analyze my infrastructure, find RCEs, have fixes, work out some sort of remediation path in my head very, very quickly is a testament to how good the UI is at delivering what is a vast amount of information in a very consumable way. So Cubescape team, thumbs up, great work. So we drilled down a little bit there, going from the top CVEs into image scanning. But let's take a look at the config scanning. From here, we get an overview of all of our clusters and the frameworks that we choose to pay attention to. I have specifically configured each of my clusters to give me the most information, or at least the most upfront information about NSA, MITRE, and SYS. I can click on any cluster and change that. We have the ability to select free. So I can say turn off MITRE, and let's turn on ArmoBest. Now when I come back here, I have NSA, SYS, and ArmoBest. And I can do this for them all. Whether I want them all to be the same or I want them all to be different is up to you. I've found that it works quite well to have them all the same, to give me a same pane of glass to all my clusters. And in fact, what we can see here with the default managed Kubernetes experience across the 3 major clouds, I won't say their name again, is that AKS, has 3 NSA failed controls, 9 SYS failed controls, and 3 ARMO best practice failed controls. The Amazon one has 2 NSA, 10 SYS, and 2 ARMO. And the Googly one has 6 NSA, 17 SYS, and 5 ARMO. So that default out-of-the-box experience is different across all of the clusters. Now, I don't know if that should have any importance in your decision making. I know I'm more likely still to go for the Googly one when required. But if security conscious decisions are one that you have to make, this may provide a good framework for helping make that decision. When we click on a cluster, we get to see the score over time again. But not only that, we can have a nice big list of the tables of all of those failed controls. We can sort them by whatever is important to us. So maybe we want to tackle all the critical paths first. Or perhaps we just want to see which ones have the most failures. So it could be here. We have the automatic mapping of a service account into 18, we have 18 failures of this check across this Microsoft cluster. So we can click on this and we'll see all the resources that this fails on. We can see that Cert Manager has a job and a service account with these properties. We can see in our default namespace, we've got all the Flux controllers. And we can actually add exceptions if we want to. So say we've made the decision that, hey, Flux is going to be Flux. And we don't mind that it has that token. We just turn on the default namespace or the Flux system namespace. It depends on how you have it deployed. Or maybe it's at Cert Manager. We're going to let Cert Manager be Cert Manager. So we're going to apply an exemption for all of that. We have the ability to pick and choose, but it could be that we actually want to remediate. So we can click on the fix and it'll take us to the YAML. And it shows us the line that we need to add to our cluster. Now, I'm not going to download this YAML or copy this object. However, this is a very simple failed control. Not all of them are going to be fixed by one line of YAML. For those more complicated cases where it might need 4, 5, 10, 20, who knows, lines of YAML, this view is going to be really good. and that we can copy and download it if we want. We can apply a diff to our existing resource and get the change that we need. Although, to be honest, this is doing a diff against your existing resource. So you could probably just copy and paste the lines that are green and off you go. Also tells you which lines are different, and we have the ability to share this with people if we want. But we're going to move on. So it's really good having this insights into the configuration changes across my cluster. We can also initiate a new scan for our cluster if we want by clicking the scan button. We can tell it the frameworks that we wish to scan for at this time. And as you'll see, I actually have a scheduled scan for 8 AM every single day running all frameworks. So a lot of flexibility and power into the way that you interact with the scanning within your cluster. And this is because of the way that we're deploying Cubescape in cluster rather than running it as a local process. Now, don't worry if you do want to run Cubescape as a local CLI. I'm going to be covering that next, along with CI/CD integration in my next video. So stay tuned. One last thing I'd like to cover as part of the configuration scanning is that we're looking at it as the lens of which controls have failed. However, it's also very useful to take a look at which resources have violations or failed controls. Now, we can sort by the kind, which may not be terribly useful. And if I see a config map with a failed control, that would be mildly amusing. However, we may wish to sort by which resources have the most failed controls. And as we can see here, it's my cert manager, which has 9 failed controls. I can click on the failed controls and I can see, we've got no memory limits, we've got no CPU limits, no resource limits, ingress and egress blocked, or not blocked, I guess. Automatic service account mapping, we have images from any registry, we're not restricting that with an allow list. There's no probes, and it does not have an immutable container file system. Now, knowing how Cert Manager works, maybe we know that it's never going to have an immutable file system. So let's exempt it. And maybe it doesn't have a way to do a readiness probe, so we'll exempt that too. And we click close. If we want to get more information on the fix, we click this banner. And now you can see we've got changes at line 55, which is to add limits and requests for memory. And the next one, we can add the read-only file system. Line 61, we can add a readiness probe. We can turn off the auto-mounting of the service account. So this ability to see how to make changes to existing resources and a way to fix the failed controls, I think is an invaluable tool. So let's jump back. We've taken a look at how to identify misconfigurations from the lens of the controls that are failing, with us getting to prioritize the controls that are important to us, or potentially the controls that we know we can fix quickly. We also have the ability to find the workloads within our cluster that are failing the most, so maybe we can identify ways to get them up to scratch or exempt them if their workloads outwith our control. In a managed Kubernetes cluster, you cannot modify a lot of the workloads running in the kube system namespace. So you're just going to have to rely on the managed provider to do their job. So exempt them if you can and if you must. All right, we have one more feature that I want to cover on Cubescape Cloud, and that is the RBAC visualizer. Understanding the scope and breadth of role-based access control within your Kubernetes cluster is a hell of a challenge. With so many service accounts, something called groups, who knows what those are, roles, cluster role bindings, the things that you need to know to understand who can do what within your cluster requires a lot of access to kube control on the command line. And maybe you're using kube control auth CANI, but there is an easier way. Enter the RBAC visualizer. From here, we can say, let's take a look at one of our clusters. I'll start off by selecting the Amazon one. Now we get this overview of all the service accounts, groups, roles, and the verbs that they can act on, the resources they can act upon. Now, by default, you get this kind of broken down look, and you can see here in this box, we have the default namespace. In fact, if I zoom in, you'll see NS default. And this, as we've seen from previous parts of Cubescape, is where I'm running my Flux CD deployment. If we pop over here, we have another box, and this time it's our Cubescape box. This is our Cubescape namespace. We'll see the workloads, the service accounts, and the roles that they have access to, and the resources that it can act upon. So we get this lovely visual description or way to interact and describe, I guess, a map of all the important RBAC stuff within our cluster. Now, what's cool is that we have the ability to tweak the way this is laid out. So first, we can say, let's group by verb. Now, at this kind of overview, that's not going to do a lot. So we'll just turn that off. What will do a lot is layout by type. Now, we can have a kind of top-down map of the workloads within our cluster, the service accounts that they consume, and we have the roles that those service accounts have. We see that this CRD controller role is used by all of the service accounts for all of the FluxCD components. And actually, Flux, being that it is a GitOps operator in a Kubernetes cluster with super special root privileges, can star on all resources. It's all stars all the time. These blue lines are the verbs that this role can enact upon the resources it can act upon. And we've got star, 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 and star. So right away, we have this really good way of seeing that Flux can do a lot of very interesting stuff in our cluster. Although that's as we expect, so not really worth calling out. Let's take a look at something else. What about Cubescape itself? Well, we have our Cubescape workloads. We've got the stateful set deployment, some more deployments. We've got the service accounts that they use. So we've got the Cubescape SA and the KSSA. This uses the KSSA roles, which has the ability to star on cron jobs. And we've got the ability to star on config maps. Over on the other side, we've got this service account, which is the SA roles, or Cubescape SA roles, which has star on namespaces and star on daemon sets. So as you can see, my cluster and this default managed configuration with just a couple of workloads doesn't really have a lot of interesting RBAC history, but it doesn't mean that we can't get some useful insights out of it anyway. We have this who can drop down. So what if we want to know who can create pods? We click the who can confirm, which shows us that pods can be created by all of these roles. We can see some system controller roles, which is as we would expect, especially for the replica set controller. And we have the daemon set controller too. So the only things that can create pods are the controllers, which should actually be able to create pods. This is good. This is exactly what we wanted to see. So let's clear the who can. And clear pods. We also have this query dropdown. This query dropdown shows you common queries that are useful for understanding common queries that people may want to ask of the RBAC within our cluster. One that I often like to ask is who can exec into a pod? And if we scroll down here, we'll see a query, show who can exec into pods. And when we run this, we see that cluster admin can, which of course you can. Cluster admin is the cluster admin role within the cluster, but also the CRD controller. So our Flux deployment actually gives a bunch of its controllers, the source controller, the notification controller, the image reflector controller, the image automation controller, the Helm controller, and the customized controller, the ability to execute commands within pods. Now, again, given the way that Flux works, we'll probably write this off as being okay. But if you've seen any other workloads in there that have the ability to execute commands within a pod, that's something that you would want to identify. Another common query could be, do I have any roles in my cluster that are not being used? Maybe I can actually clean some of this stuff up. Well, we can say show unassigned roles. These are all system roles, so not things we really need to worry about. But again, in a more production-like cluster, and we'll do some work on one of my real clusters in a coming video soon, we can actually identify when maybe we've had workloads that created roles and we've removed them, but the roles have been left around. roles lying around in your cluster are potential attack vectors for other people, for people that have access to your Kubernetes API. So it's generally best to clean them up. The last feature I'll show off in RBAC Visualizer is the Investigate button. This is when you want to work out how one individual resource or a few resources work or collaborate with other things in the system. So I'm going to start by clicking Clear, and then I'm going to click Investigate. From here, I get a list of subjects, roles, resources, workloads, role byte verbs, and API groups. Now, it could be that I want to understand the Flux CD API group. I can do Customize, Source, Helm, Notifications, and Image. Not only that, I'm curious about a workload. Maybe I want to understand how the Helm controller functions. From here, we can see the CRD controller role and the resources it can act upon because of the filter on the API group. We can see the deployment Helm controller because I added it as part of the workload selector. We can now explore just these resources with the Helm deployment controller. I can right click and say, well, show me your service accounts. And we can see the service account here. I could also right click and say show related resources. And now it pulls in both the roles that it has access to and all the resources that it can act upon. So now I have a pretty good understanding of the permission model for the Helm controller in just a few clicks. So that's been today's video. Taking a look at Cubescape Cloud by running Cubescape in my clusters across all three major cloud providers with a couple of default workloads. I've been playing with Cubescape and Cubescape Cloud for the last week, and I've got to say I'm really impressed. You get a lot of bang for buck with just a simple Helm deploy to the cluster passing on one simple value. From there, I'm able to understand misconfiguration, vulnerabilities, and RBAC. These are three things that are notoriously and infamously hard to understand within the Kubernetes context. It's a lot of information that needs visual paradigms to be able to get fast understanding. So I hope you find this video useful. Go check out Cubescape Cloud and Cubescape. We'll be back in a few days with another video looking at Cubescape CLI and how we integrate that into CI/CD pipelines. Until next time, I'll see you soon.